Let's start with a reminder of generic rectangle. Part A. Review what you've learned in Lesson 811 by writing the area of the rectangle at the right as a sum and as a product. So when we're writing as a sum, we're just listing the tiles that we see. We've got a 10x squared, then we can combine the like terms, which would be negative 39x plus 14. When we're writing it as a product, we have to think about what numbers would have been on the outsides of this rectangle as a length and a width that would multiply in to make those. So I'm going to zoom in. I notice that here, these have what I would call a common factor. Both numbers have an x, and both numbers could have a factor of 5 in them. So I'm going to put a 5x on the outside, and to get 10x, I would need to multiply by a 2x to make 10x squared. And that makes sense because there's also a factor of 2 in these boxes. Now we can finish the rest of the rectangle. The 5x would need to multiply by negative 7 to make negative 35x. And then along the bottom, 2x multiplied by negative 2 would make negative 4x. And we can check that negative 7 times negative 2 would make positive 14. So to write this as a product, we just write those outside length and width in parentheses. We'd have a 5x minus 2 and a 2x minus 7. And the order does not matter. Something new is called a pattern for the diagonals. So what we need to look at is these diagonals. Is there something special about these diagonals compared to this diagonal? And there is. In all rectangles, if you multiply the numbers in the diagonal, something special will happen. So 10x squared times 14 would make 140x squared. And if we multiply negative 35x times negative 4x, we also get 140x squared. This multiplying diagonal rule works for all rectangles. We're going to use this rule of multiplying the diagonals and finding the length and width to help us write this quadratic that's currently in the sum to rewrite it as a product. So what we know about this is we typically put and I'm going to use colors to help us, the x squared term and the constant term in the diagonals of a box. So we'll put the 2x squared in the bottom corner and the 6 opposite of it. And then we know that these remaining two boxes, even though they're empty, need to add together to make 7. So what that means for us is whatever these two missing numbers are, if we add them together, they're going to make 7x. So I'm going to put that 7x down here because I need to add two numbers to make 7. We also know that this diagonal, if we multiply it, it should make the exact same multiplication as this diagonal. So since the diagonal multiplies to be 12x squared, we know that our other blue diagonal needs to multiply to make 12x squared. And now this is a diamond problem that we've solved before. What two numbers can we pick that are going to multiply to 12x squared, but will add to 7? So for example, I might think, oh, 6 times 2 is 12, but that doesn't add to 7. 3 times 4 is 12, and that does add to 7. So I'll do 3x and 4x. Those are the missing numbers that need to go into my rectangle. So we will put in 3x and 4x. Doesn't matter where they put them. Now all we have left is to find the outside dimensions and write it as a product. So we're going to put 2x multiplied by x will make a 2x squared. 2x times another 2 would make 4x. And 2 times 3 would make 6, or x times 3. So we write our answer as a product, x plus 2 and 2x plus 3. This is called a factored form. You previously called it writing it as a product. I'll do one more example of this factoring process to help you remember the steps. So we'll start by putting our x squared term and our constant term diagonal in the rectangle, 6x squared and 12. And we know that if we multiply those together, that this multiplied diagonal will be what our other diagonal also needs to match. So 12 times 6 would be 72x squared. And then we know that the 17x is what our two missing rectangles should add up to. So we'll put 17x as the sum and 72x as what they need to multiply, or 72x squared as what they need to multiply to. So I need to pick two numbers that multiply to 72 and add to 17. 6 times 12, but that doesn't add to 17. We can pick 9x times 8x would make 72, and 9 plus 8 would make 17. So we'll put 9x and 8x into our generic rectangle, and now we just have to pick the missing lengths and widths. So I notice that 6 and 9 have a common factor, so this will be 3x multiplied by a 2x. And then the 3 times 3 would make 9, and 2x times 4 would make 8. And I double check, 3 times 4 is 12. So I write my answer 3x plus 4 and 2x plus 3. This is writing it as a product, but we now call it factored form. Here's a couple factoring problems that you can practice on your own. Try making the rectangle and the diamond, see if you can get them into factored form, pause the video, and then restart it, and I'll have the answers here for you to look at. The font is a little small, so here's A and C. And then B and D, which is not factorable. There is nothing that multiplies to -9 but can add to 5.